Hi viewers, welcome to Learning Electrical Engineering channel. In this video, we will see how to draw the Norton equivalent circuit for a given circuit diagram. As we know that the Norton equivalent circuit is a current source is in parallel with a resistor. So the current source we will draw like this. This is IN and a resistor is connected in parallel with the current source. This is Rn and this is the terminal A and this is terminal B. Now we need to find the two values, that is In and Rn, to draw the Norton equivalent circuit of a given circuit diagram. As a step 1, we will find the value of current In. To find the value of current In, we need to do the short circuit of the terminals A and B, and the amount of current flowing through the A and B is In. Now we will apply the nodal analysis and the KCL to find the value of In. Now we will mark the junction. Let us say this is junction J1, and the amount of current flowing through the 3 ohm resistor is I1, and the amount of current delivered by the current source is I2. The amount of current flowing through the 3 ohm resistor is I3, and the same amount of current I3 will be flow through the A and B terminals because the current will follow the low resistance path. Okay, or we can say the 6 ohm resistor and the fully short circuited path both are in parallel, so the equivalent resistance will be very low. So the amount of current flowing through the A and B is equal to I3. Now we will apply the nodal analysis to find the value. So let us say this is node V1 and this is node node 1, and the voltage at this node is V1. This is node 2, voltage at this node is V2, and this is the reference node V0, which is equal to 0 volt because it is in ground potential. Now we will apply the KCL first. So as per KCL, the incoming currents to the junction is I1 and I2, and the outgoing current is I3. So we can write I1 plus I2 is equal to I3. Fine. Now the value of I1 is equal to V1 minus V2 by 3, as we know that V1 is equal to 15 volt. So we can directly write 15 minus V2 divided by 3 plus I2. We know that the amount of current delivered by the current source is 4. We can directly write from the circuit diagram, and which is equal to I3. I3 is equal to, here the potential difference is V2 minus V0 because V0 is directly connected here. So V0 is equal to 0. So we can write V2 divided by 3 ohm. Fine. On simplification of this equation, we will find 15 minus V2 plus 12 is equal to V2, as the negative term of V2 is available here when we are transferring to the right hand side. So it will become 2V2 is equal to 27 and V2 is equal to 13.5 volt. As we have found V2 is equal to 13.5 volt, the current flowing through the 3 ohm resistor is I3 is equal to V2 minus V0 divided by 3. As we know that V2 is equal to 13.5 minus 0 divided by 3. This is I3. So I3 is equal to 13.5 divided by 3 will be 4.5 amps, and which is equal to IN, that is 4.5 amps. Now in step 2, we will find the value of Rn. For that we need to turn off the independent sources. Here the voltage source was there and we have removed by short circuiting, and here the current source was present, and we have open circuited the current source. Now when we are looking from the terminals A and B, we will find the equivalent resistance of the circuit. So when we looking from the circuit, we can draw the 6 ohm resistor as it is. This is 6 ohm resistor, and here when we see in this circuit diagram, 3 ohm, 3 ohm resistors are connected in series and in parallel with 6 ohm resistor. When the resistor are in series, it will be added up, and the value of this series combination will become 6 ohm. We have drawn it here, and this is terminals A and B. Now when we see both are in parallel combination, so 6 ohm is in parallel with the another 6 ohm resistor, so the equivalent resistance will be Rn is equal to 36 divided by 12 ohm, which is equal to 3 ohm. So we have found the value of Rn also. Now we will apply the value of In and Rn into the equivalent circuit. So we have found the value of In is equal to 4.5 amps and Rn is equal to 3 ohm. So this is the Thevenin's equivalent circuit for the given circuit diagram. If you have any doubts, please write it on the comment box. I will reply. If you like this video, kindly hit the like button below this video. If you have not subscribed my channel, kindly subscribe it. Thank you so much.